when you say the quality of your trained model, well, you can use the RSS value, the residual sum of squares, right? That is indeed a good indicator of your quality, the quality of your model. When RSS value is small, then your model is very well trained on your training data point. When RSS value is big, then maybe there is something wrong, or linear model is not good model for fit your training data point. There are huge bias error. I don't know. But RSS value is great, but there is still some cons, some drawback. Let's consider this simple comparison. You have some data set of which data range is -100 to 100. This is data set 1. The second data set belong to some range -0.1 to 0.1. Okay, then even if your first model for dataset 1 is very well fitted and your quality is very nice, because of irreducible error, there can be very huge RSS value. On the other hand, because y is belong to -0.1 to 0.1, you didn't learn anything and you just guess everything is 0, then your RSS value is very tiny because your output range is very small, from -0.1 to 0.1. Okay, so let's compare the quality of your trained model for data 1 and the very naive algorithm for data set 2. If you use RSS value for this comparison, you have to say, okay, the naive algorithm for data set 2 is better than the very nice model for data set 1. Is it good? No. So that's why statisticians invent R-squared metric. So R-square value is total sum of square minus residual sum of square over total sum of square. Here total sum of square is equal to sum from I1 to n, the total number of data point, training data point, yi minus yi bar. So here yi bar is empirical mean of your training data point. Okay. Of course, output training data point. This is 1 over n summation yi I1 to n. So what is the meaning of R-squared thing? So total sum of square is total variance. You output RSS. This is kind of remainder, residual thing. Remainder after fitting. Then TSS, total sum of square minus RSS, this value essentially imply the amount of explained information. So if this value is big, then your model will explain the input and output pair of your training data point. And since we normalize the numerator by total sum of square, and always total sum of square and residual sum of squares are positive value, R square thing always less than or equal to 1. And RSS value, if your algorithm is not stupid, always smaller than or equal to total sum of square, R squared value is greater than or equal to 0. And as close to 1, we can say your model well trained. As close to 0, we can say okay, your model output is totally independent to the data point.